Hello, welcome to the second video on NPS configuration. In our previous video we looked at basic remote access server and NPS configuration. In this video we will look at NPS server advanced configuration and look at configuring a basic network access protection NAP system. Both of these topics will be covered heavily in your 7411 exam. We're going to break this video down into two parts. In the first section, we'll look at configuring an NPS server as a remote radius proxy server. In our example in the previous video, we used our NPS server as a centralized authentication, authorization and accounting server. So a radius client, our RAS server, passes on authentication requests to the radius server, which is our NPS server. But an NPS server can also act as a radius proxy. As a radius proxy, the NPS server makes decisions on how best to treat authentication requests. And its decisions really are: does the NPS server itself handle the authentication and authorization request? Or, based on certain conditions, does the NPS server pass on those authentication requests to another NPS server? This can be useful in situations such as corporate mergers, where you want to centralize all the VPN access through one access or one set of access servers, but you haven't migrated user accounts and computer accounts yet. So our NPS server can pass on the relevant authentication requests to relevant forests. Or in scenarios where, as an organization, you sell remote access services to your customers, but the remote access customers maintain their user and computer accounts. In this way, our radius proxy can pass on the appropriate authentication requests to the relevant customer servers, but we still maintain the remote access server infrastructure. In the second part of this video, we will be looking at network access protection and specifically configuring VPN connections to challenge their clients for statements of health to prove that those clients are healthy before they're allowed into our network. And that in essence is what network access protection is all about. A machine could be authorized, a user can be authenticated and authorized, but does the machine have an antivirus application installed? Does the machine have its firewall turned on? Well, with NAP we can perform checks like that and more and make decisions based on the results of those checks. So if the firewall is turned on, then that machine is considered healthy. If it's not, it's considered unhealthy and then either denied access to the network or placed into a remediation network where it can become healthy. Now, NAP sounds like an excellent service for our network, and indeed it's a service provided by other manufacturers as well as Microsoft. And that's probably why Microsoft have chosen to de-emphasize this service in Windows Server 2012 R2. So I would not expect to see further development of this product in other Windows Server releases. However, it will still play a part in your 7411 exam. There will be several questions on this service, so it's something you should study. But before we get to NAP, let's take a look at the NPS service again and look at the components that we configure to make the NPS server a remote radius proxy. Here we are back on our NPS server. I'm using exactly the same configuration as in our first video. So my domain controller is acting as both a DC and an NPS server. And in this first video, we looked at how network policies can be configured to authenticate and authorize connections. Well, what we didn't do yesterday was look at this set of policies: connection request policies. You see, when an NPS server receives a connection request from a radius client, it doesn't necessarily handle that traffic itself. It doesn't go straight to its network policies and make decisions on whether the user should be allowed in or not. Instead, the first thing that happens is that when a NPS server receives a connection request from a radius client, it takes the details of that request and checks them against a connection request policy. And just like our network policies, we have a built-in connection request policy. Connection request policies, just like network policies, are made up of several different components. If we take a look at our built-in connection request policy by right-clicking it and going to Properties, we can see these various components. Now, first of all, we can see this policy is enabled, which means this policy will be checked when connection requests are presented by our Radius clients. And then, just like our network policies, we have conditions. Now, the default condition says 24 hours a day, 7 days a week. That's the default condition. If I say add, you'll see a very similar list of conditions that we can add here, very similar to the list that we saw in the network policies in the previous video. So this default policy says 24 hours a day, 7 days a week, but it's not saying deny access or grant access. Connection request policies say, in this example, 24 hours a day, 7 days a week, that this server should authenticate all requests. So 24 hours a day, 7 days a week, this server handles all authentication requests. And indeed, 24 hours a day, 7 days a week, this server also handles all accounting requests as well. And that in essence is what this connection request policy is doing. It's saying that it's asking a question: who should handle the authentication and authorization requests? This server or someone else? Now, if we click on the under settings, if we click on the authentication methods, you'll see there's no authentication methods defined by this connection request policy. So what happens is that a connection request is received by the NPS server from one of its Radius clients. It then checks the connection request policies, the default one saying 24 hours a day, 7 days a week, we will authenticate all requests. It would then, because it's handling all authentication requests, pass those authentication requests onto the network policies for processing. And as we saw in the previous video, the network policies then will decide if someone's allowed in and what they can do once they're in there. So it will authenticate, it will authorize, and set constraints on their session. Now, using these connection request policies then, we can create additional ones to forward different types of requests to different NPS servers. Now, to do that, we need to identify which NPS servers we're forwarding requests to first. So up here, under Radius Clients and Servers, we have the Remote Radius Servers group. This is a list of remote Radius servers, NPS or other industry standard Radius servers, that I can pass connection requests on to. Now, I don't have a group of servers here, so let's right click and say New, and we'll give this group of servers a name. So let's say we have a partner organization called Widgets, and my NPS servers and my RAS servers are handling all the market connections for the Widgets organization, but they keep control of their authentication and authorization policies. So although I'm accepting the connections from the outside world, I'm then going to pass them on to the Widgets servers. So if I say add here, I can type in the name or IP address of the remote Radius servers. Now, I don't actually have these servers configured, so I can't verify these connections, but what I will do is just type in an IP address. So that would be the IP address of the NPS server. And I know that Widgets has got at least 2 of these servers. So we'll handle, we'll configure 2 IP addresses for Widgets. So this becomes then a list of servers that I'm going to pass information on to. Notice here the priority section and wait. Priority column, wait column. These 2 columns determine which of these remote Radius servers I will pass connections on to first. So with priority equal of 1 and wait equal of 50, both servers should be used equally in a round-robin fashion. But let's say server 100.0.0.1 is by far the better server, and this is the server I want to use unless it's unavailable for some reason. Well, what I can do then is go to the 100.0.0.2, edit the properties, and under load balancing, change the priority of this machine to 2. The lower priority value wins. So if you have 2 remote radius servers, one with a priority of 1 and one with a priority of 2, then all my connection requests will be passed on to 100.0.0.1 first, and only if that's not available will we pass requests on to 100.0.0.2. If, however, the priority is the same, then we use the wait value to determine not who we connect to, but how often we connect to a machine. So this time, the priority is the same for both servers, but 100.0.0.1 has a weight of 50, 100.0.0.2 has a weight of 100. Now these are relative weights. So with these two figures, 50 and 100, it means I will pass on twice as many connection requests to 100.0.0.2 than I would to 100.0.0.1. We'd get exactly the same results if the figures were 25 and 50 or 100 and 200. These weights are relative to each other. If we change the weight back to its default setting and leave the priorities of 1, then again both servers will be used equally in a sort of round-robin fashion. So they're my widget servers. They're the servers at my partner organisation, my remote radius servers. But we need a way of determining which traffic, what type of traffic we will pass on to the widget's devices. Now again, that's where the connection request policies come in. So if I say to create a new connection request policy, remember the default policy says 24 hours a day, 7 days a week, this local server will handle all authentication requests. So what I want is a second policy, and we'll call this widgets connection request policy. If we could spell. Now, just like our network policies, we add conditions. The conditions list is slightly different to network policies, but a lot of the conditions are the same. And what I'm going to do is use the username condition. And what we're going to say is if the username has this connection string. So if the username has anything at widgets.com, and we'll say as long as the connection is using L2TP or PPTP, so as if the connection has, the username has that connection string, and if the connection is using L2T or PPTP, then pass the authentication request onto the widgets remote radius server group. We can also say that the account information is also passed on to widgets, or leave the account information on our NPS server. Remember, by account information we're talking about login, and we can log both the text files and to SQL servers. So if I say next and finish, there we have our connection request policies. But remember, just like network policies, the order in which these policies are listed are important. Because at the top of the list we have a policy that says 25 days, 7 days a week, we will handle all connections, then that's exactly what will happen. So we need to make sure our widgets connection request policy is moved up in our list. Now, if the user connects with a name that has that string and they're using L2T or PPTP, then we'll forward requests to the widget's remote radius server group. So this is it really. Right now my NPS server is acting as a remote radius proxy for this particular type of connection. Again, we can see that in our policy that we've created, the authentication methods have not been defined for our policy. We're presuming then that the network policies on the remote radius servers will also then provide the type of authentication that needs to be used by the users and the type of authorization that's going to be enforced. One final note on this as well. We are now acting as a radius client for those remote radius servers. So it's important that details of our NPS server are added as a radius client on the widget's radius servers. If the widget's radius servers don't add us as a radius client, then they will not accept connection requests from us in the same way that we wouldn't accept connection requests from our remote access servers. So if we flip back to our PowerPoint presentation just for a second. So this is what we have configured then. Our workstation will pass requests onto its VPN server by configuring its VPN client. The VPN server, acting as a radius client, will pass requests onto its NPS server. Then the NPS server will use its connection request policies to decide whether it should handle the authentication requests or pass them on to a second NPS server. On that second NPS server, we need to add a radius client, and we'd have to configure then network policies. To make all this work, on the NPS server, we had to configure a remote radius server group, and we had to configure connection request policies. So now we've got a handle on NPS and connection request policies, we need to take a look at network access protection. Network access protection, NAP, has been around now for a couple of Microsoft operating system versions. As I said previously, Microsoft intends to de-emphasize this product, so I would not expect to see further releases of the Windows operating system to include this role or advancements on this role. Microsoft's key decision, or key reason behind this decision, was because first of all, other services provide this kind of facility now on Microsoft networks. But also with the advent of direct access, your clients will spend more and more time connected to your network, so we have more control over their health state. But again, as I said previously, NAP will play a big part in your 7411 exam. There will be several questions on this process. Now we're looking at NAP in relation to VPN connections, but no matter how you're planning on challenging clients to prove their health, via a wireless access point, a network switch, via IPsec policies, or indeed through DHCP servers, all types of NAP enforcement involve the same three configurations on your NPS servers. We're going to start off by configuring System Health Validators, or SHVs. Think of SHVs as being little programs that control what you want to check. They're lists of settings that identify whether you want to make sure that the antivirus is turned on, that you want to make sure that the antivirus is up to date, that anti-spyware is up to date, and you use these to detail what types of checks you want to perform against, in our case, the VPN clients trying to connect in. Now, System Health Validators are then used by health policies. Health policies say what it means to be healthy and what it means to be unhealthy. So if all System Health Validator checks are passed, then a system is deemed to be healthy. If they fail one or more checks, they're deemed to be unhealthy. Health policies themselves, though, do not determine what happens to healthy and unhealthy connections. So in turn, health policies are used by network policies. Now, network policies decide what happens next, really. If a connection matches the healthy health policy, then the connection will be granted unrestricted access. If the network policy matches the unhealthy health policy, then the connection will be given restricted access. So it's the network policies that determine what should happen based upon the health checks that have been carried out, or rather the results of the health checks that have been carried out. So we'll look at these three components on our NPS server. We'll also take a look at configuring a custom connection request policy as well to support NPS. And then we'll take a look at the client-side configuration. There are several elements you'll need to configure on the client side in order to support NAP integration. So if we leave the PowerPoint presentation and if we flip back to our NPS server. So here we are on our NPS server, and we're going to start our NAP configuration here on the NAP access protection section. And we have two sections here: system health validators and remediation server groups. Now, the remediation server group would be a list of servers that unhealthy devices that are not compliant with your health policy, these are devices that they can still access. So if your health policy says that all updates rated critical or above should be installed, and we do health checks and find they're not installed, then the remediation server group might contain WSUS servers. If we say that the health policy says that the antivirus application should be up to date, and we find that the antivirus application is not up to date, then the remediation server group might contain antivirus servers where new antivirus definitions can be downloaded. Now, we're not going to be configuring a remediation server group for this exercise, but what we will need to configure are system health validators. Now, out of the box with a Server 2012 deployment, there's a single system health validator called the Windows Security Health Validator. This validator makes checks in conjunction with the Security Center application that exists on your client machines. So it's important that we either use group policies or local configuration to enable Security Center. Now, this health validator, if we have a look at its configuration, this health validator works with either XP machines or Vista, Windows 7 and Windows 8 computers. Now, the types of checks you can do against Vista, Windows 7 and Windows 8 computers are all the same, XP slightly different. And I say slightly different because there is only one item that we can check for Vista 7 and 8 machines that we cannot check with XP. And if I click on Vista 7 and 8, we'll see that straight away. You see this section here, spyware protection. We can see that spyware protection. If I click on the XP section, then spyware protection is removed. So all the other checks are exactly the same, but with Vista 7 and 8, you can also check to see if anti-spyware application is on and if it's up to date. And then that's what this system health validator is about then. You can see we can tick, for example, is the firewall enabled for all network connections? Is the antivirus application on? Is it up to date? If we scroll down, is automatic updates enabled? Is SUS settings set up? And are we meeting these configuration settings? So these are type of checks that the built-in system health validator can make. Now, we're going to keep it very simple, and we're going to say that the system health validator should check whether the Windows firewall is enabled for all network connections. But you can see how you can combine different combinations of these settings to check various aspects at the same time. Now, that's the default configuration. You can actually configure several sets of configuration options. So you have different levels of checks for different sets of clients, different groups of clients, and that can be reflected in your different policies. Now, as we said, the system health validators themselves don't restrict anyone. The system health validators just outline what type of checks you want to create. What type of checks you want to perform. They are then used by health policies. And for our example, we're going to need 2 health policies. We'll call this one our VPN Healthy Health Policy. And we're going to say if the client passes all of our system health validator checks, and we will select the default system health validator. So if the client passes all SHV checks, then it's considered healthy. And we're going to create a second health policy called VPN not healthy. And for this one, we're going to say if the client fails, and we've got different options here, but I'm going to say fails 1 or more SHV checks, then it's considered not healthy, or it's considered to match the VPN not healthy health policy. So the health validators are used by the health policies. In turn, the health policies are used by network policies. Now, this has still got the same configuration that we used in the previous video. You can see NPS policy 1 is still enabled. So we're going to disable that, just so that when we configure and test this, we know it's the NAP configuration that's performing the checks and not the NPS policy 1 that's allowing the client access. So I'm going to create 2 network policies here, and we're going to call this one VPN Healthy. And we're going to say that condition, instead of Windows group this time, we're going to say the condition matches the healthy health policy. So if the client connecting matches the healthy health policy, and as we said, the healthy health policy says as long as all SHV checks are passed. So if the client matches the healthy health policy, then grant access. Now, we're not only concerned about authentication methods here, we're going to configure our authentication methods via the connection request policy in a little while. So what I'm going to do here is say this policy performs machine health checks only. Then under configure settings, we have the NAP enforcement section, and you can see the different options here for NAP enforcement. So by default it says allow full network access. So if our client matches the healthy health policy, then allow full network access. We could also say allow network access for a limited period of time, or we can say allow limited access. But as these machines will be deemed to be healthy, as long as the antivirus, the firewall is turned on, then we want to give full network access. Now we're going to move this up our list, so it's at the top of the network policy process in order. We're going to create a second policy. We'll call this VPN not healthy. And this one, we're going to say match the not healthy health policy. So if the connection matches the not healthy health policy, remember this one says if you fail 1 or more SHV checks, then grant access. So if it's not healthy, still grant access. And I still want this policy to perform machine checks only, health checks only. But this time, it's going to be limited access. Now, when we configure network access protection, we can configure different enforcement methods. VPN enforcement is just one of those. We can also configure DHCP enforcement, 802.1x wired, so switch enforcement, 802.1x wireless, so wireless access point enforcement, and we can also configure IPsec enforcement as well. And the different enforcement methods have different ways of restricting access. For VPN access, we would configure filters, IP filters. These IP filters then would restrict the communication between the unhealthy client machines and the rest of the network. Now that restriction could be complete restriction, it can't connect to anyone else, or it could be that the client can connect to the remediation server group. Now other enforcement methods like DHCP would place people on, would give people DHCP clients a 32-bit subnet mask. IPsec enforcement methods put people onto a different zone where they can only access remediation servers. Wired access can place unhealthy machines on a different VLAN. But for VPNs, it would use IP filters to restrict the access of non-healthy machines. Now notice also on this health policy, we're saying allow limited access, and for VPNs it would use its filters. We've also got this auto remediation. Now I'm going to disable that, but what that would mean is, if possible, remediate the client. So if a client is not healthy, make them healthy. Make them healthy so you can give them access to the network. Now I'm going to leave that disabled on this policy, and we'll come back later on and reconfigure that. So we've got my not healthy policy. Let's move that up our list. So 2 network policies, VPN healthy, VPN not healthy. Each of those use their health policy as their condition, and the health policy are using the SHVs and identifying what has to be passed, which will identify what has to be passed in order for the machine to be healthy. Now the final component we need here is a connection request policy. It's the connection request policy then that's going to identify the type of connections that will perform NAP checks on, and the type of authentication we expect those clients to use. So we'll call this VPN NAP connection request policy. I'm going to identify the access servers as remote access servers. And we're going to say conditions. We're going to say add. And here we're going to choose the type of connection that we're going to apply network access protection to. So I'm going to say if a connection comes in using L2TP, PPTP, or SSTP, so tunnel types. Look at the 3 main VPN protocols. So if a connection comes in that matches one of these 3 protocol types, then perform authentication and accounting locally, but this time we're going to say manage authentication as well. So this is the difference between our previous connection request policies. The previous policies would identify just whether this NPS server or a remote NPS server handles the authentication, but then they would pass authentication control down to the network policies. For NAP, our connection request policy also enforces the level of authentication we're going to be using. And that level of authentication for network access protection with VPNs is protected EAP. Protected EAP. Now EAP is a certificate-based authentication protocol. So prior to configuring NPS for network access protection, you would also need to make sure that the NPS server and remote access servers have a computer authentication digital certificates, that they both trust the authority that the digital certificate is been issued from, and that the client itself as well, the workstation machine that we're going to be performing checks against, that it also trusts the certification authority. Now I've already done that. I've issued a certificate from my enterprise certificate authority to my NPS server and to my remote access server, and I've made sure that everyone trusts my internal enterprise authority. So if I say to edit this EAP type, we can see that it is enforcing network access protection there, that it's picked up the certificate to use, which is my computer certificate for this, in this case, domain controller, but NPS server. It's enforced access protection there, and that's the important tick box. So if I OK that, there's not a lot else we have to do here. And we don't need to select any other authentication method, although if you wanted to choose other authentication methods, you could. So on this next page, we just say next and finished. And just like our network policies, let's move this to the top of our list. So it's going to be checked first. And what we'll do is disable the other connection request policies. Again, just so that we know that it's this connection request policy that's allowing our connection through. Just as a reminder, my remote access server, my RAS server, is still configured as a Radius client here. So it's still enabled as a Radius client. But also, we've ticked the box for the Radius client to say this Radius client is NAP capable. That's an important tick box. If not, then NAP checks won't work. So the RAS server is ticked NAP capable. Now the system health validate's in place, the health policies, the network policies, and the connection request policy. Then the NPS components here are done. What we need now to do is flip to the client and have a look at a few of the client settings. So here we are on workstation 1. And before we look at the VPN connection itself, there are a few settings that we need to make sure are configured on workstation 1. Now this MMC here that I'm just going to run as the administrator. And we're going to add a couple of snap-ins just for us to take a quick look at. So if I say add remove snap-in, and the first one we want to look at is the network client configuration snap-in for the local computer. And we also want the group policy object snap-in for the local computer as well. Now there's a couple of things here. First of all, in order to interact with the NAP enforcement servers, the servers challenging us for statements of health, we need to make sure the appropriate enforcement clients are enabled. And you can see here the different types of enforcement client, and that I've enabled the EAP enforcement client and the VPN enforcement client. At a bare minimum for our VPN connections, you would have to have the EAP quarantine enforcement client enabled. The second thing we need on the local machine, because our built-in, our default system health validator works with Security Center, we need to make sure that Security Center is also enabled on this local computer as well. So we can see there that Security Center is also enabled. So that's two things. The final thing we will need to check is to make sure that the network access protection service is also configured and set to start up automatically. So there we've got the network access protection agent service, and that agent service is configured to start automatically, and it is running. So on the client machine, the agent service, Security Center, and the appropriate enforcement clients need to be enabled. Now all of that can be enabled through group policies, all three of those things. If you want to enable it through GPOs, they can also be configured from the command line. In particular, the enforcement clients, NetSH, has a set of subcommands for network access protection. Now, if we take a look at the VPN connection itself, just sign in as administrator, we can see the IP address of our remote access server, and under security, that we're using the same EAP protocol for authentication that we configured on our NPS connection request policy. So we'll do one more thing, and that's take a look at the Windows Firewall. So there we go, Windows Firewall is enabled. Windows Firewall is enabled for all connections. So we'll right click and we'll say to connect. So that looks good. That looks good. We are connected there, but we've connected in previous videos. So let's try something different. Let's disconnect. And this time what we'll do is we'll turn off the Windows Firewall. So turn off the Windows Firewall there. Now remember, our system health validator is doing that one check. Is the firewall turned on? If it is, the health policies say we've passed all checks, we are healthy. So the network policy said allow us in. If the firewall's turned off, the health policies say we're not healthy. So the network policies say allow restricted access. So let's just try connecting. And there we go, we have connected. But not a very good demonstration in that, you know, we connected with it enabled, we connected with it disabled. So let's just change our policies a little bit. Let's leave things turned off, and let's just flip back to our NPS server. So here we are back on our NPS server, and what I'm going to do is make one change, and I'm going to make the change to our not healthy health policy. Oh, sorry, our not healthy network policy. I apologise. So if I got the properties of my not healthy network policy, and this policy says if the connection matches the not healthy health policy, then grant restricted access. But let's change that. Let's say if the connection matches the not healthy policy, then deny access. So the policy is enabled, but we've changed the result. If this condition is met, if we fail one or more SH3 checks, then deny access. So let's flip back to our client. So back on our client, again this time the firewall turned off, and let's try to connect to the VPN. So there you go, we try to connect to the VPN. This time it says a policy is preventing our access. And the policy is preventing our access, so we can't get in. And that's because this time we are not healthy, and the not healthy policy says deny access. So that is sort of NAP in action, but we can give you another demonstration. Let's go back to our NPS server. We're back on our NPS server, and let's change it up a little bit. Again, we're still looking at our network policies here. But this time we will say our not healthy policy, grant access, but this time we will say to enable auto remediation of clients. Auto remediation. So allow access, but if you can, auto remediate, fix the problem that was stopping our user from getting in, or stopping our computer, from getting in, or stopping our computer from being healthy. So let's flip back to the client. This time, back on our client with the firewall disabled, we'll try to connect. It allows the connection in, but see what happens to the firewall. We've allowed the connection in, but this time the health policy has remediated my connection. It's turned my firewall back on. If I go to turn the firewall off, so now we're in the network, we turn the firewall off, and we give it a second, firewall comes back on. Again, this is NAP in effect now. When a client is challenged for a statement of health and proves that it's healthy, in the background the NAP agent service and the NAP enforcement clients continue to monitor that element. So when they fall out or are changed anyway, with auto remediation enabled, we are automatically turned back on. Let's disconnect. And we'll do one more check, one more demonstration. Let's flip back to our NPS server. So here we are back on our NPS server, and we're just going to do a couple of things. First of all, we're going to disable auto remediation. So we're going to remove auto remediation for our health policies, both our not healthy policy. I'm going to say this policy denies access again. So if we're not healthy, deny access. And our healthy policy that allows access, we're going to make sure that again auto remediation is disabled. So auto remediation is disabled on both policies now. So if we go back to our client, here we are back at our client, disconnected a minute with the firewall enabled. And what we'll do is connect into the VPN. So we'll connect into our VPN there. And this time we will disable firewall. So the firewall stays disabled this time because we've removed the auto remediation feature, but see what's happened to our VPN connection, it's immediately dropped. So again, the NAP policies, the NAP agent on this side, the NAP enforcement client are monitoring this component that the SHVs are saying to check. And because of the change in status, they present a new statement of health to the NAP service. The NAP service recognizes the client is now not healthy and immediately disconnects. If we try to connect, error 812, can't connect. Turn the firewall on. And we try to connect. And there we go. So we can see the benefits of network access protection. Machines are forced to go through a series of checks to prove how healthy they are before they're allowed onto our network, using, as we said, various enforcement methods, this one being the VPN enforcement methods. I think the tricky thing for the exam is understanding the different components, how they fit together, and making sure you understand the flow of those components. Let's take a quick look back at our PowerPoint slides. So from an NPS perspective, these are still the three main components for configuring a NAP system: your system health validators, your health policies, and network policies. Each one doing a slightly different task to make up the network access protection components. We also configured a connection request policy that then includes the type of authentication we expect our NAP clients to perform. And then don't forget we configure the client side. I did it manually, you can do it with group policies. That client side involves configuring the NAP agent service, the appropriate enforcement client, and making sure for the default SHV that the security center component is enabled. Make sure you understand the components of NAP. Have a look at the 4 or 5 different enforcement methods in general and have an understanding of how they work. Pay particular attention to the VPN and the IPsec enforcement methods. The IPsec enforcement method in particular, you might find detailed questions in your 411 exam. Make sure you understand the role of connection request policies NPS and how they work with the remote radius server group. And also take a look at other videos on the 7411 topics that you'll find on this site. Thank you for your time. We'll see you again soon.